All right, so here's number 4. And the first thing that I'm going to look at is this denominator. And that is a Pythagorean identity. And secant squared theta minus 1 is actually equal to tangent squared theta. So I'm going to make that substitution first. And that is according to the Pythagorean identity. Then I'm going to go ahead and use my reciprocal identity and my tangent identity. So I'm going to change secant squared theta into its reciprocal, 1 over cosine squared theta. And I'm going to change tangent squared theta into sine squared theta over cosine squared theta. Now notice here is my main division bar. So I have a fraction divided by a fraction. So by the definition of division, I multiply by the reciprocal of my denominator. And then my cosine squared thetas will divide out to make 1. So I'll have 1 over sine squared theta with that multiplication. And then by the reciprocal identity, that is cosecant squared theta. All right, moving on to number 5. Now in this one, notice I have multiplication on the left, and then I come over here and I have subtraction on the right. So the only way that I'm going to get subtraction in my problem is if I put it there. So I'm going to start by taking this sine squared theta and substituting it according to the Pythagorean identity. So according to the Pythagorean identity, that sine squared theta is equal to 1 minus cosine squared theta. So I did that substitution. Next, I'm going to go ahead and distribute this tangent squared x. And so that's going to give me tangent squared x minus tangent squared x times cosine squared x. So I'm going to leave my first tangent squared x alone, and I'm going to change my second tangent squared x into sine squared x over cosine squared x according to the tangent identity. And then I'm going to carry out that multiplication in my second part here. My cosine squared x divided by cosine squared x is 1. And so then I'm going to have tangent squared x minus sine squared x. And that is what I was trying to prove. So moving right along to identity number 6. Here I had, don't get too overwhelmed here, I had sine theta plus cosine theta squared plus sine theta minus cosine theta squared. So remember, when you square something, it means to multiply it by itself. So you need to go ahead and write that out. Do not distribute that little 2. Write out the thing that you're going to multiply. And then go ahead and do your distributing. So I've got sine times sine gives me sine squared. And then I'm going to have a sine times cosine and a cosine times sine, and I'm going to combine those like terms and get 2 cosine theta sine theta. And then when I multiply cosine times cosine, I get cosine squared theta. All right, then similarly, I'm going to come over here and I'm going to distribute. And I'm going to get sine squared theta minus 2 cosine theta sine theta plus cosine squared theta. Now that I've carried out all of that multiplication, do you see I have 2 terms here and here, and they are opposites of each other. So those are going to add to 0. And then I'm going to bring everything else down. And so I have a sine squared theta plus cosine squared theta and another sine squared theta plus cosine squared theta. Well, each one of these sine squared theta plus cosine squared thetas is equal to 1 by the Pythagorean identity. So then I have 1 plus 1, which is 2, which is what I was trying to prove.